Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Greater Noida. The subject that I deal in this semester for BTech 7th semester students is optoelectronics and optical communication, and the topic that I discuss today is polarization. Polarization, mm, so try to understand this concept of polarization. What is polarization? Polarization is nothing but it gives the it gives the direction of electric field, right? So uh, as you know, in any communication, when you want to convey the you know any information at some distance uh, in a certain area, what you have to do, you have to send the signal with a process that we called as a modulation, right? So in modulation, you have to change one of the parameter according to the message signal. So you have to change the parameter of your carrier according to one parameter of your message signal. So uh, if you if if you want to change, if you want to change one parameter in any signal, because each signal has its polarization, right? Each signal has its particular direction of electric field. So this means that each signal has its own polarization. But actually in optical fiber, what's happened, the polarization change every moment. As the signal travels, its polarization change, right? So polarization state change automatically, not with according to the message signal. So you can't convey message at the receiver by changing polarization according to the message signal, because polarization state cannot you know cannot you know cannot remain same. It's change automatically, it's change. So what we prefer in optical communication, we prefer intensity modulation. Intensity means we have to change the intensity according to the message signal. Intensity of light, or you may say on off keying. This is also come in the category of intensity modulation. Means presence of light, there is intensity of light, represent 1, and when there is no light, darkness, represents 0. So we prefer intensity modulation rather than, or OOK modulation rather than polarization modulation. We can't, because polarization of the signal is not maintained or uh, change at every moment as the signal propagate. So that's why okay, I read this particular paragraph, so you also understand that also. I already give you a concept. Cylindrical optical fiber do not generally maintain the polarization state of the light input for more than a few meters. Means polarization state change every moment. It's not stay, and hence for many applications involving optical fiber transmission, some form of intensity modulation of the optical source is utilized, that we already talked. The optical signal is thus detected by the photodiode, which is sensitive to optical polarization or phase of the light wave within the fiber. Means your receiver, your photodiode, actually at receiver, photodiode is a type of device that sense this optical signal and convert it into current. So the photodiode actually that we use in receiver is sense intensity rather than optical polarization. So nevertheless, system and applications have been investigated which could require the polarization state of the input light to be maintained over a significant distance. So certain application and certain devices has to be investigated. By using that, we have to maintain the polarization state of a signal inside the fiber at least at some distances. and fibers have been designed for this purpose. So special types of fiber has been designed that have the capability to stay its polarization state at some distances. So these fibers are single mode, and generally these fibers are single mode. So single mode fiber, we have a special type of single mode fiber that have the capability to maintain a polarization state at a certain distance. So these fibers are single mode, and the maintenance of the polarization state is described in terms of a phenomena known as fiber birefringence. So fiber birefringence is a phenomena that we will discuss in next slide. So what is this fiber birefringence phenomena? Single mode fiber with nominal circular symmetry about the core axis allow the propagation of two nearly degenerate modes with orthogonal polarization. And actually what's happened, fiber birefringence is a phenomena. Sometimes what's happened, in a single mode fiber, when the signal propagates, automatically two modes are degenerates with orthogonal polarization. Means in single mode fiber, what's happened when the single mode fiber travels through optical fiber, then after some time two modes are degenerate, मतलब दोबारा से generate हो गए, and with orthogonal polarization, मतलब the polarization state of these two degenerate modes are perpendicular to each other. If one mode have a polarization in x direction, another mode has a polarization state in y direction. That's why we called it orthogonal polarization. So they are therefore bimodal, supporting HE x11, HE y11. These are the two modes. These are the degenerate modes, where the principal axis x and y, and x, y are of course are perpendicular to each other. That's why we say orthogonal, right? So hence in an optical fiber with an ideal optically circular symmetric core, both polarization modes propagate with identical velocities. So this is a fiber birefringence, means two modes are degenerate with orthogonal polarization. This is the main point of this fiber birefringence phenomenon. Look at this. This situation is illustrated in this particular figure, where the incident linear polarization, which is at 45 degree with respect to x-axis, becomes circular polarization pi by 2, and linear again at pi. This process continues through another circular polarization at 3 pi by 2 before returning to the initial. Try to understand this point. Look at this figure A, right? Okay, look at this figure A. You know, when the mode propagates through a optical fiber, this is the state of polarization. This is linear polarization. This is in that direction. Look at the direction, right? After and because the polarization state is unstable in optical fiber, after some time it becomes circular, and in that direction. For example, say this is clockwise direction, right? So this is linear in that direction, then becomes circular in that direction, clockwise direction, again linear in opposite direction, what we had in this initial stage. Now again becomes circular symmetry, but this time opposite to that one. Means if this is clockwise, this become anti-clockwise, and again change its polarization state, become a same state. So fiber start propagating from this point, change its polarization state continuously, and reach to the same state after a certain distance, and that distance is called beat length. Look at the beat length. So this particular polarization state is at 5 over 2 pi. This state is at 3 pi by 2. This state at pi. This is pi by 2, and after that it becomes that, and you are the observer to see that phenomena. So this is the beat length. Beat length means this is the length traveled by the particular mode to have the same stage of polarization as the mode started at the beginning, right? So this is a phenomena. So again, LB is the beat length. The characteristic length LB for this process corresponding to the propagation distance for which a 2 pi phase difference accumulates between the two modes is known as the beat length. So in short, we can say that beat length is the length traveled by a mode to have the same state of polarization, right? So if this is the easy definition to describe that phenomenon and beat length. Thank you very much.